The first thing I want to talk about is a concept known in programming as scope. And this scope is something that we've actually come across already in our programming. But I wanted to leave it until we've seen functions, we've seen if and while loops, different types and blocks of code before we start talking about this really important concept. Now, if you want to visualize this concept, imagine you have a house with a fence around it and you plant an apple tree inside your garden. Think about who can access those apples. Just you and your family, right? But what if instead you had an apple tree in the neighborhood, by the sidewalk, for example? Well, this is kind of free for all. Anybody can go and access those apples. This is a starting point for how to understand scope. Head over to the AppRury Day 12 Start Replit and go ahead and fork your own copy of it. Take a look at the code that's in the starting file in the main.py and try to understand what it's doing. First, I create a variable called enemies and I set it to equal 1. Then I create a function called increaseEnemies and I try to set that variable to 2. Finally, I call my function, triggering all the lines of code inside. And now I want you to predict, what will this print statement print in the console and what will this print statement print? And it might not be what you expect it to be. So I would expect that here I've got a variable which is equal to 1. When this function is called, this variable enemies should now be equal to 2. So when it's printed down here from outside my function, this should be equal to 2 and this should also be equal to 2. But look at what happens instead. I get enemies from inside the function equal to 2, but from the outside the function, it's equal to 1. So what's going on here? To really understand this, we have to understand the concept of scope. And scope is a really, really important thing in programming. You see it in every programming language. And although it's a little bit different between the programming languages, it all goes back to that concept of the apple tree being within a fence or outside a fence. So let's take a look at some other examples before we come back to solve this problem. The first thing to think about is a concept called local scope. Local scope exists within functions. So for example, if I was creating a game and I had a function called drink potion, which is somehow going to strengthen my player, well, maybe it would have a variable that's created inside the function. So it could be something like potion strength, and I could set that to start off with a value of 2. Now, in this case, if I was to go and print this variable potion strength from within the function, notice I'm indented here. And of course, I need to call this function for that to happen. Notice what happens when I run the code. It's equal to 2. That's what we would expect, right? But notice what happens if I try to print the potion strength from outside the function, here. This firstly gives me an error right when I'm writing it inside the editor. And when I try to run it, it gives me an error inside the console. And the error is a name error. And it tells me that the name potion strength is not defined. Clearly, I've defined it here, but why can't I access it outside the function? Well, this goes back to the concept of local scope. When you create a new variable, or indeed a new function, inside another function, it's only accessible. You can only use it when you're inside that function because it has local scope. It's only valid within the walls of this drink potion function. What if we wanted it to be accessible outside the function? Well, now we need to think about something called global scope. The only difference between global scope and local scope is where you define or where you create your variables or your functions. So let's say we have a different variable. Let's say that I created a variable called player health and it starts off being equal to 10. Now let's say later on I have the same drink potion function And this potion has strength of 2. So now inside my function drink potion, if I wanted to print my player health, even though it wasn't defined within the function, this is perfectly possible. And if I call my function drink potion and then run the code as it is, you'll see 10 being printed. So this has a global scope. It's available anywhere within our file because it was defined at the top level of the file. Now, when I say top level, I don't mean physically at the very top of the file. I mean that it's not within another function, like potion strength here, because this is defined indented inside a function. So this is a local variable, whereas this is a global variable. And global variables are available within functions, no matter how deep it gets nested, and it's also available outside of functions. This concept of global and local scope doesn't just apply to variables. As I alluded to before, it also applies to functions and basically anything else you name. This is a concept called the namespace. So we defined this variable player health. We defined this function drink potion. Anything that you give a name to has a namespace. And that namespace is valid in certain scopes. This concept of scope applies to basically anything you name. If I was to nest this function drink potion inside another function, let's call it game, well, this drink potion now has local scope within the function of game. So this is why this line is now erroring out, because it can't actually see inside this function. So now, in order to call this drink potion, I have to be within the 4 walls of the game function. So whenever you give name to anything, a function or a variable, you have to be aware of where you created it. Now, it's easy to notice where you've created functions. We have the def keyword, right? But when you create a variable, that's the first time that you give it a name and you set it equal to something. And where you write that line of code defines the scope of that particular variable. Here, it's outside of every other function, whereas here, it's inside a function, actually nested 2 levels deep, so it has local scope to this function. Now, unlike some other programming languages, if you've come from, say, C++ or Java, there is no such thing as block scope in Python. What this means is that if you were to create an if statement, say if 3 is greater than 2, and if you were to create a new variable inside an if block or a while loop or a for loop, basically any sort of block of code that's indented, this does not count as a fence. It still has the same scope as its enclosing function, or if there's no enclosing function, then it has global scope. So let me show you a full example. Let's say we had a list of enemies. So the enemies could be skeletons, zombies, or aliens. So now if I was to define a game level, right, like the level that the user is currently playing at, let's say they're on level 3, and I create an if statement and I check if the game level is less than level 5, well, in that case, I want to create a new enemy, but I don't want the enemy to be too difficult to beat. So I'm going to pick from the list of enemies and I'm going to pick the first one. Notice how even though this new enemy is a variable that's created within this if block, if I go outside the if block, so I'm not indented at all anymore, and I try to print this new enemy, this is perfectly valid code. And if I run the code, you'll see skeleton being printed. But notice how as soon as I embed this within a function, so let's define a new function, and now this line errors out. Because within the function there is local scope, so now this new enemy is available anywhere within this function because blocks like if, while, for, all of these blocks of code with colons and indentation, they don't count as creating a local scope. So in order to print this new enemy, I actually have to be within the boundary of this function, which means my code has to be here. The most important thing to remember from this is if you create a variable within a function, then it's only available within that function. But if you create a variable within an if block or a while loop or a for loop or anything that has the indentation and the colon, then that does not count as creating a separate local scope. Coming back to our original example, I want to talk more about the global scope and the concept of modifying something within the global scope. Here we have enemies, which is a variable that has global scope. And here we have a function which creates a local scope. Now we think that we're tapping into this variable and setting it to 2. But in fact, we're actually creating a completely new variable that's entirely separate from this one. And this is why when we printed it here, it showed it was equal to 2. But when we printed it here, it showed it was actually equal to 1. If you want to make this a little bit more obvious, I can call this a skeleton and I can set this to be a zombie. And when I hit run, you can see again, this prints zombie, this prints skeleton, because these two variables are actually entirely different things. And we're not changing this right here at all. We're just creating a new variable that has a local scope. Now, it's usually a terrible idea to call your local variables and your global variables the same name. But in this case, what we actually wanted to do was we wanted to modify this variable. We wanted to do something like maybe plus equals 1. And notice how as soon as I write plus equals 1, then my editor starts going crazy and tells me that this local variable enemies is defined in an enclosing scope, is referenced before assignment. What does that mean? It means that the editor thinks you're trying to tap into a local variable that you defined somewhere around here. And then you tried to modify it by adding 1 to the previous value, but you actually haven't defined it. What we wanted to do though is we wanted to tap into this variable and change it here. In order to do this, we actually have to explicitly say that we have a global variable, which is called enemies, that's defined somewhere outside of this function. And that is the enemies that we want to use inside this function. So it basically takes that global enemies into the function and allows you to modify it. Without this line of code, we cannot modify something that is global within a local scope. Now, there's a reason why it's so difficult to modify something that has global scope. You probably don't actually want to do this very often because it's confusing and it's prone to creating bugs and errors. Because this variable with global scope could have been created anywhere in your code, right? And you would be modifying it completely independent of when you created it. So it might have been days between when you wrote this code and when you wrote this code, and it just makes everything more fallible, more easy to fail. This is why very often people will tell you when they're teaching you Python to avoid modifying global scope. You can read it, that's not a problem. You can use it within your code like we are here. But don't try to modify it within a function that has local scope. But what can you do instead? What if you wanted to have this functionality, like a function that changes the number of enemies? How can you achieve this without modifying the global scope within the function? Well, you could use what we learned about return statements instead, right? What if instead of modifying the enemies, You actually just simply returned it as the output. So return the current value of enemies plus 1. Now, once you call this function, you'll get hold of the outputs and you can save it to the global variable enemies. So this now means that this function can be taken away and placed anywhere in your code, and you don't actually need to know how it works. As long as you know that this is how you increase enemies, then all you have to do is just call it. Remember, you should be careful with variables that have global scope, but don't believe the people who tell you that you should never use global scope. Global scope can be incredibly useful, especially when you're defining constants. Global constants are variables which you define and you're never planning on changing it ever again. It's just something like, for example, the value of pi, right? You want to look it up once and you want to put it into your code and you never want to look it up ever again. And every other time you want to use it, say inside a function, then all you want to do is just tap into that value of pi. So usually, in order to differentiate these constants, which you're pretty much never going to change, from the variables, which you're likely to change, the naming convention in Python is to turn it into all uppercase. For example, if you had pi or you had a URL that you needed to use, or you have some sort of Twitter handle, then these are all going to be uppercased, separated with underscores. What this means is that later on in your function, and you want to use one of these global constants, as soon as you type it, you can see it's uppercase and you know to remind yourself to not modify this inside your code. Now that we've talked a little bit about scope, it's time to put your knowledge into action. Head over to the next lesson, and I've got a quiz that will test your understanding. So for all of that and more, I'll see you there. Now that you've completed some of the scoping problems, it's time to tackle the final project. This final project is a little bit special because now I think you've got enough experience and enough skills under your belt to actually create this project entirely from scratch by yourself. So you're flying solo now. Now, the first thing I want you to do is head over to guessthenumberfinal.apiary.repl.run, and I want you to play this game quite a few times actually, just so that you get a good idea of how it works. Now, the first thing it tells us is welcome, and then it tells us it's thinking of a number between 1 and 100, and then we get to choose a difficulty. So I'm going to choose hard. Now it tells me that I have 5 attempts to guess the number, and I'm gonna make a guess. Now it tells me that 50 is too high. It's not the number that it was thinking, and I have to guess again. And notice how I started out with 5 attempts. I'm now down to 4 attempts. So let's try 25. So 25 is too low, but 50 is too high. So that means the number is somewhere in between there. Let's try 30. Again, too low. Let's try 40. Too high. Maybe it's 45, but I only have 1 attempt left because I went for the hard level. And as expected, I didn't manage to get the right number, and I've now run out of guesses, so I've lost. If we run again, we can try playing this on an easy level. On an easy level, we get 10 attempts instead of 5. That gives us a little bit of extra opportunity. So let's try 50. 50 is too high. 25 is too high. 10 is too low, so it's between 10 and 25. So let's try 15. Now, if 15 is too high but 10 is too low, then we're pretty close to the answer. It's now between 12 and 15. Let's try 13, 14. There we go. The actual answer that it had in mind was 14. And I had 4 attempts remaining to get the final answer, and I managed to get it at the end. Play through this game at least 3-4 times on the different levels. And remember that the easy level has 5 goes. The hard level, the user gets 10 goes at guessing the number. and look at how the code works and how it's functioning. And then I want you to break down this problem. Write a to-do list, create your own list of tasks that you need to solve, and start with the simplest one. And once you've tackled that, start putting in some comments into your code. Write down the functionality your program needs, and then write the code. And then test out your code and keep going until you've tested it and made sure that it works in all situations. So this final project has no starting code. I'm not going to give you any comments or to-dos to start off with. I want you to try and tackle this entire project by yourself. And the only thing I'm going to give you is this link so that you can try out the final project. And I know that there's a lot of ways that you can cheat, but don't do it. Have faith in yourself. If you tackle this for an hour, I'm pretty sure you're going to get there in the end. You have free reign on the styling or the wording, whatever it is you want it to say, but it has to have the same functionality. Now, this also means that if you want to get some ASCII art of your own, then you can head over to this website, which I'll link to in the course resources, and just type the name of your game. So maybe it'll be guess the number. And you can change the font that you want for it. Maybe something a little bit isometric, or maybe ogre, or maybe train, whatever it is you want. And then once you're happy with the font, you can select and copy everything that's on there. And then inside your project, you can create a new file called art.py and then create a new variable and set it equal to the design that you've got in mind. Now, in order for it to look right, you actually have to create this as a docstring. So 3 quotation marks to begin with, and then 3 quotation marks to end. And then just make sure you have enough horizontal space to display the whole thing in one go instead of it being truncated when you have a little bit of space, and you should be able to see the actual design. Pause the video now and create this number guessing game by yourself as the final project. How did you get on? Hopefully you managed to complete the project and you're just here to check through the solution. Now, if you haven't given it a proper go, and I mean at least an hour at tackling this, then go back, keep going. It's only when you struggle that you actually get better. You can watch me type code all day long and it's not going to make you a better programmer. So I know you're going to try really hard, and I want you to try really, really extra hard and make sure that you can complete each of these projects by yourself. I mentioned that this one doesn't have a starting REPL, so we're going to start out with our own. And you can call it anything you want, but I'm going to call it Guess the Number Game. Now, when you're creating a new project from scratch, like we're doing right now, it can seem a little bit intimidating staring at a blank screen. The first thing to do is to just divide up the project into individual components. So while you're playing this game, you can see that there are different bits of it that we need to complete, right? The first one is printing all the starting parts of the game. The next one is trying to figure out how to set this difficulty level. Getting the user to type in a word, easy or hard, and then changing the number of attempts based on that. We can already start thinking about maybe we need to make a function to set difficulty. And then we need to let the user make a guess, right? So they're going to guess a number. So let's say I'm going to type in 50. And then we have to somehow check that guess against the number that was originally selected, and then check to see if it's too low or too high. So now we have some additional parts of our program, right? We need some sort of way of choosing a random number between 1 and 100. So that's the first thing that's probably going to happen in our code. We need to have a function to set difficulty. We probably need some sort of functionality to let the user guess a number. And we'll also want to check that number that they've guessed against the number that we originally had to see if it's too high or too low. So probably a function to check users' guess against actual answer. Now, notice how every single time I make a guess, my number of attempts go down. So we also need to track that, right? Track the number of turns and reduce by 1 if they get it wrong. Now it's looping back again to this stage where we're making another guess. So if 50 was too high, then maybe we'll guess 25. We have to have some sort of way of repeating this part of the code, right? We're going to repeat it as long as they have attempts left and they are wrong. Now, if, however, they get it right, so I think I have a good chance of getting it right. So if 25 is still too high, let's try 12. And there we go. When I get the answer right, it tells me you got it. The answer was 12. So now we've got some of the basic parts of our code down in comments, and we can start thinking about how to write it out, right? Let's start by tackling the easiest one, which is choosing a random number between 1 and 100. All we have to do for this one is just to import the random module, or even better yet, from the random module, import the randint function. Now, inside our code, we can simply just use randint. We can say the answer is equal to a randint that is between 1 and 100. And of course, remember that randint includes A and B, so both 1 and 100 can show up. In addition to this, we probably have to give the user some of these messages. So I'm just going to copy some of these messages. So I'm going to print welcome to the guessing game. And also I'm going to print that I'm thinking of a number between 1 and 100, like that. So now we've got an answer that they need to guess, and we've got a little bit of starting text for them. The next easiest thing in this is to figure out a way of letting the user guess a number. So we know that we'll need an input to ask them to make a guess. So we can copy this part and we can use that as the prompt. And then we're going to have to save their guess and convert it to an integer. So they're going to be typing a number here, right? And we'll call this guess. Now the user is able to guess a number. And we now have to figure out some sort of way of checking the user's guess against the actual answer. This is probably a good time to create a function. So why don't we go up to the very top and create our function here. We'll call this check answer. And we're going to pass in the user's guess and the actual answer in order to achieve this checking functionality. So in this case, we're going to check to see if the guess is greater than the answer. Well, in this case, it's too high, right? So we'll just print too high. Now, what if the guess was actually less than the answer? Still not equal to the answer, but in this case, it's too low. So now the final condition is they actually got it right. So you could write elif guess is equal to answer, but you could also just use else because there's no other possibilities. This else statement catches the moment when they actually get it right. So in this case, we're going to print what we have here, and then we're going to print out the answer. So of course, we're going to replace that with whatever the actual answer is and turn this into an F string. So now that's that step done. And let's think about what else is easy that we can knock off the list. Let's make a function to set the difficulty. So up here, in addition to our check answer function, I'm going to create this other function, some way of setting the difficulty. So let's call this set difficulty. And it's probably not going to take any inputs. It's just going to do some sort of action. So when we first start off the game, it already asks us to choose a difficulty. So I'm going to copy this text and I'm going to put that into an input. Choose a difficulty, easy or hard. And then we're going to save this probably into a variable, which I'll call level. So the level of difficulty that they want. Now, if this level that they chose was equal to easy, well, in this case, we want to set the number of attempts that they have to 10. So they have 10 attempts. But on the other hand, if they chose hard, then they only have 5 attempts. So this is probably a really good time for creating a global constant. So we already saw this in the previous lesson on scope, but this is a really nice thing because it means if we create this global constant at the very top, then if we want to switch around how our game works, we can really easily access these constants by just scrolling to the top of the page. Let's call the first one easy level turns. So the number of turns you get on easy, which is going to be 10. And then we'll have hard level turns, and this is going to be equal to 5. Now I've got these two constants, which is global, and I can use it inside any of my functions or basically anywhere on this page. If the level is easy, I'm going to set the number of turns to equal the easy level turns. So this is going to be a number, right? Else, so if they chose hard instead, then turns should probably be the hard level turns. Now, setting it here is no use. I actually need it inside my game. So now going back in my game, I need to let the user know how many number of attempts, how many turns they actually get. To start off, I'm going to use a print statement that just prints the number of attempts they have remaining. And it's not always going to be 5. Sometimes it's going to be 5, sometimes it's going to be 10. So what I'll need is some sort of way of tracking this number of turns, right? But how do we know how many turns they get? Well, it depends on what they chose here, right? If they had chosen hard, then turns should be equal to the hard level turns. If they chose easy, it should be equal to the easy level turns. So instead of using this as some sort of global variable, which I have to change inside here, which would require me saying global and then turns so that I can access this particular variable and change it inside these steps, it would be much, much better if I just returned these values as an output from this function. If this is set as return, then I can simply call this function setDifficulty, which is going to trigger this input. And then once the user has set it, then the output is going to be the actual number of turns they have. And I can now use it inside this print statement to show them how many turns they have. Now, I've already written quite a bit of code actually, and it's probably a good time to run the code. While I'm testing my code, it's probably a good idea to actually see what the answer is. So we can add a bit of testing code that just prints out what the actual answer was selected as. And if we run the code now, you can see we've got the starting part pretty much down. Welcome to the number guessing game. I'm thinking of a number between 1 and 100. And then we've got our little hint here. The actual answer is 63. So we have to make a guess, and I've really noticed that that input needs a space here so that I'm not writing right next to the colon. So let's say I guessed 50. Now it's asking us to choose a difficulty. So I've already got a little bit of a problem here. I should actually have this before the other part. So I should choose the difficulty and then make a guess. So now let's stop and run and see if we've fixed that bug. And you can see, yep, indeed, it asks us for a difficulty first. So I'm going to choose easy, and it tells me that I've got 10 attempts remaining, and then to make a guess. And if I choose hard instead, then it tells me I've got 5 attempts. Now, if while you're playtesting this game and you realize that actually 5 is not enough, then all you have to do is scroll to the very top of the game, change this one global variable here, and all your changes will be reflected in the code below. Now let's get back to our game. Let's say I make a guess and our code ends, right? Even though I've got my check answer, it's not actually being called anywhere. So let's go ahead and call that function, check answer, and then we can pass in the user's guess that they made at this step. And we can also pass in the correct answer, which comes from here. So let's run our code again. So I'm going to choose the easy mode and I'm going to make a guess. Now 50 is too high because I can actually see the answer. It's meant to be 32, so that works, but I can't guess again. It's not letting me. It's actually ended the program. So we probably have to tackle this particular to-do if we actually want to get the right functionality. How do we get the guessing functionality to repeat if they get it wrong? So that, as you might have guessed, is probably going to require some sort of while loop. While they've gotten it wrong, we probably should go and let them make a guess again. These parts will definitely need to be repeated. So let's create a while loop. What are we going to check in our while loop to make sure that it keeps on going? Well, the thing that we're trying to aim for is to get the user to guess the actual answer. If we set the while condition as while guess is not equal to answer, then that pretty much guarantees that these lines of code will keep going until the user actually gets the right answer. Now, however, when we do this, we get an error. Undefined name guess. Well, because guess hasn't been declared yet. So why don't we declare it outside of the while loop and simply just create it as a variable? So we'll set that to equal 0. Now, at the moment, this is a global variable. This is a global variable. This is a global variable. So it's probably a good idea to put our game functionality inside its own function. So we can create a new function here, which I'll call game. And now we'll need to call and trigger this game inside the global scope if we actually want this to be carried out. Now that we've done all of this hard work, let's run our code and let's try it out. Let's go for easy. And I'm going to start off by guessing 50 as always. 50 is too low and I can see the answer is actually 90. So I'm going to go for the next number. Let's try a number that's a bit too high. 95, too high. Now, what if I actually get it right? What if I actually guessed 90? Well, it tells me you got it. The answer was 90. So the only thing that we're not really doing is tracking the number of turns so that we tell them you have 10 attempts, you have 9 attempts, you have 0 attempts. And if they get 0, then they're going to lose, right? Here we have this print statement that runs only once because it's not inside the while loop. So let's tackle our final to-do to track the number of turns and reduce it by 1 if they get it wrong. Now, where do we know that the user got it wrong? Well, inside the check answer function. If it's too high, if it's too low, then we have to deduct the number of turns they have. But if they got it, then we don't. One way of tackling this is, again, creating a global variable called turns, set it to start off at 0, and then inside this function, we simply just say turns minus equal 1, and also turns minus equal 1 when it's too low or too high. Now, because this is a global variable, we again would need to say global turns in order to use it inside our function. But as I mentioned, this is not a good idea because it means that you're modifying the global function within a local scope. How can we achieve the same functionality without having to use a global variable? Well, we could instead just pass in the number of turns that we currently have, and then inside our function, we can return the number of turns minus 1. And we can do the same down here. So now, when we call this function check answer, we can pass in the current number of turns, which remember got set by the set difficulty function, and we can pass that into here. Because it's not immediately obvious that this function actually has an output, it's probably a good idea to add a docstring to this function. Remember the 3 quotes, and then in between we're going to say checks answer against guess, returns the number of turns remaining. Now, when we actually call check answer, you can see that this is what actually happens and that we have a return that we can be aware of. If this is going to be the number of turns remaining, then we can save that to this variable turns so that we update this local variable every time we check the answer. Now, this part is a little bit mind-blowing, so you might actually want to put this through Python Tutor and step through it step by step to see what's actually going on and how this turns variable is being updated by the output from this function. If you're totally happy with what's going on, then feel free to keep going. So now let's check out our code. 50 is too high and 20 is too low and 38 is just right. Now, what if I actually ran my number of turns down to 0? So let's try hard, because this is only going to give us 5 attempts. So let's say I guessed 50 and then 70, and then I'm just going to put in some random numbers so that I end up with no remaining guesses. You can see it's actually not stopping me, right? And also, for some reason, we have a bug where the number of attempts we have remaining is not actually being printed. So let's address that issue. Well, if we want it to happen every time and repeat, it's going to need to go into the while loop. Instead of printing our number of turns here, why don't we print it here inside the while loop instead? So let's make sure the indentation is correct. And now let's try it again. So I have 5 attempts remaining. Let's make a guess. I have 4 attempts remaining. And notice how it's counting it down. 3, 2, 1. This should be my last guess. But notice how it actually keeps on going. It doesn't stop the game. I can keep going, and it's going into negatives now. How can we fix this? We need some sort of way of tracking when this number of turns goes down to 0. And when that happens, we have to stop the game and tell them that they've lost. Why don't we create an if statement, check if the number of turns is equal to 0, and print something. Let's check the actual final version. Let's see what happens in this case. When I run out of goes, I make a guess, it's too low, and it tells me you've run out of guesses, you lose. We can print that here as well. But notice how if we run the code as it is, so let's just keep guessing the same number until I run it down to 1. So now I make a guess, it tells me you've run out of guesses, you lose. But it's still letting me keep going, even though I've lost. How can we make our game end? Well, luckily, we've got our game inside a function, which is being called at the very beginning. Now, remember that with functions, you have the return keyword. You can return with an output, or you can just write return for it to exit and end the function. So now, with that return keyword in place, once I run out of turns, see what happens. It stops and it doesn't let me guess anymore. Perfect, we've managed to get that right. The final thing that we're still missing is this prompt for the user to guess again. Now, this is kind of optional. It depends on your own feel for the user experience. I think it makes sense to say it's too low, guess again, because it's kind of telling them to do something. Although this make a guess also prompts them to make a guess. So you can have it, you don't have to. If you wanted to have that, then you probably actually have to check that they still have turns remaining. And if they do, then make sure that the guess is not equal to the answer. So they haven't got it right within this turn. And then to print that guess again. So now every time they get it wrong, but they still have remaining guesses, it should say too low, guess again, or too high, guess again. But if they actually get it right, so the answer should be 83, then it says you got it, the answer was 83, without asking them to guess again. Now we've pretty much completed this code. Of course, you could have added additional art, so you could have created an art.py and then used the text to ASCII generator to create a ASCII art. And then back in here, we could have imported it. And we could put that at the very beginning of the game. But the rest of the customization is basically your own, right? You're free to do whatever it is that you want to, and to change the wording, to change the text. The really important part was that you were able to play this game, understand how it worked, and then break down the problem into smaller pieces that you could tackle one by one. And if you had trouble actually completing this program by yourself, then you should have noticed when we were walking through it, when I just broke down that big problem into smaller chunks, how much easier it became tackling each of the smaller things, right? Letting the user guess a number or choosing a random number between 1 and 100. You can definitely do parts of this. And as you built up the game, towards the end you realized, this was missing, or that might be nice. Then you could start adding more and more bits to it. So if you wanted to review the final code that you see here, you can of course head over to the Guess the Number final replit at this particular link in the course resources. But hopefully you've actually managed to build out your own version, and it's even better than what I've done. And if you're particularly proud of it, be sure to share it so that the rest of us can take a look and have a play with it as well. So I hope you enjoyed the project today, and I'll see you tomorrow.